Physics part 332. The field lines cannot cross, and consequently there is a point X known as a neutral point where there is no resultant magnetic field because the two fields are equal in magnitude but opposite in direction. We've got an example for you. A circular magnet is made with the North Pole at the center, separated from the surrounding circular South Pole by an air gap. Draw the magnetic field lines in the gap. Now it's your turn. Draw a diagram to illustrate the magnetic field between the south poles of two magnets. Two bar magnets are placed on a horizontal surface. Draw the two magnets and sketch magnetic field lines around them. On your diagram, mark the position of any neutral points. Magnetic effect on electric current. The earliest discovery of the magnetic effect of an electric current was made in 1820 when Ørsted, a Danish physicist, noticed that a compass was deflected when brought near to a wire carrying an electric current. It is now known that all electric currents produce magnetic fields. The size and the shape of the magnetic field depends on the size of the current and the shape configuration of the conductor through which the current is traveling. The magnetic field due to a long straight wire may be plotted against using apparatus illustrated in the figure. Note that the current must be quite large, about 5A. Iron filings are sprinkled to the horizontal board, and a plotting compass is used to determine the direction of the field. The figure shows the field pattern due to a long straight current carrying wire. The lines are concentric circles centered on the middle of the wire. The separation of the lines increases with distance from the wire, indicating that the field is decreasing in strength. The direction of the magnetic field may be found using right-hand rule. Imagine holding the conductor in the right hand with the thumb pointing in the direction of the current. The direction of the fingers gives the direction of the magnetic field. Similar apparatus to that figure may be used to investigate the shapes of the magnetic field due to a flat coil and to a solenoid, a long coil. The figure illustrates the magnetic field pattern due to a flat coil. The field has been drawn in a plane normal to the coil and through its center. A solenoid may be thought to be made up of many flat coils placed side by side. The magnetic field pattern of a long solenoid, that is a coil which is long in comparison with its diameter, is shown in the figure. The field lines are parallel and equally spaced. Over the center section, the solenoid indicating that the field is uniform. The field lines spread out towards the ends. The strength of the magnetic field at each end is 1/2 that at the center. The direction of the magnetic field in a flat coil and in a solenoid may be found using right-hand grip rule as illustrated in the figure. Grasp the coil or solenoid in the right hand with the fingers pointing in the direction of the current. The thumb